Hi guys, I hope you are having a very great weekdays. And today we are going to be looking at BFS of a graph, and we're going to see how level order traversal is different for a graph and for a tree. Can one of you quickly confirm that you're able to hear and see me properly? I'm looking at your comments. So we are finally moving on to the hard questions. So BFS of a graph is considered a huge deal, and many people say that they are not able to do it. So we are going to be doing very hard question today, and I'm waiting for one of you to quickly confirm that you can hear and see me properly. Yeah, okay, awesome. So you are able to see me. So today we are going to be looking at BFS of a graph. Now, how is it different from BFS of a tree? So if I am over here, so this is how tree was, right? And we used to say that we are going to go from level to level. So we used to say that we are first going to go to this level, then this level, then this level. Now, when we are dealing with trees, how is it different? But with trees, what happens is, I'm talking about a directed graph. I'm talking about a directed graph, not a tree. So when I deal with graph, what happens is that when I come over here, then I could be visiting here, then I could be visiting here. Like the concept of levels is a bit abstract over here, so we have to understand. So there is basically, to understand, the easiest way to do is take a source node. Basically, from wherever we are going to start, we are going to call that as a source node. And what we are going to do is we are going to see the distances of all the nodes with respect to this node. Okay, so our source is going to be our like reference point, and from there we are going to see all the distances, and the all the nodes which are at distance 1 are going to be like level 1. All the nodes that are going to be distance 2 are going to be considered level 2. All the nodes that are at distance 3 are going to be considered as level 3. So in order to make it very simple, this is the easiest way to understand. Let me now give you more examples. Suppose there are like a bunch of nodes like this. Let's just connect them, randomly like this. I'm just connecting them randomly. So this is an undirected graph. Okay. Now we could be taking literally any one node as the source node. Suppose I pick this as a source node. Now, which are the nodes that are directly connected to it? So this is the node, this is the node, this is the node. So these are the nodes that I will consider at level 1. So level 1, level 1, level 1. Now, which are the nodes that are connected from this level 1 nodes? So if this is the one that is connected, so this is level 2. Now this is the one that is connected level 2. Now again, this is the one that is connected again level 2. So these are the nodes that are going to visit in level 2. But in graphs, what will happen is that we can always, come back to the same nodes. Because see, I start from over here. Let me take another column. So if I start from over here, I come to here, I come to here. Now from here, what might happen is that I might go back over here and come back over here. So essentially, there's a cycle. So what happens is that when we come across a cycle, we'll end up visiting the nodes again and again. So suppose I'm at node 1, then 2, then 3, then 4. Suppose 4 is again related to 1, then again 4 to 1, then again 2, 3, 4, then again 4 to 1, then again 2, 3, 4. So I'll end up in a what? I'll end up in a endless while loop, right? So we don't want that. I want you guys to quickly confirm that you are able to understand what I'm saying. So here, first thing that we saw is that we have to take a source node, and then from the source node we have to check the distances. So when we talk about levels, we are going to talk about the distances. Now after that, what I'm saying is that the distances are fine, but in graph, how is it going to be different is that we have to make sure that we don't end up in a cycle. Now, how are we going to make sure that we don't visit the nodes that we have already visited? That is the one thing that we have to do. Okay. So let's get to the question that we will be doing today. Let me just quickly open it for you. So this is the question that we are doing today, and I hope you are able to understand this properly. Yeah. Yes, Shivai, Paris, Mansoor, thank you so much for confirming. So let's get to the code part. Okay, so this is the question that is given to us. We are given a directed graph. The task is to do a BFS traversal on this graph starting from 0. So in this particular question, we are already given the source node. The source node over here is what? It is 0. Okay, so I am going to be starting from this node. And what am I doing? This is my first level, 1, 2, 3. This is the second level, which is 4. So here they have made the diagram in a very easy way. So it is very easy to understand the levels. But in reality, it will not be the case. The graphs can be very, very complex, and the examples will be as well. So we have to think of all the examples and make very random graphs to really understand that, okay, why we can end up in a cycle like that. Here again we have to start from 0. So this is one level, this is another level, 1 and 2. Okay, so we have to do a graph, so we have to do a BFS. So BFS again, what is it? It is level order traversal, right? So firstly, we have to return a vector of integers. So I'm just going to make it vector of integers res. Now what do I need to do is I need to make a queue. Now the interesting part over here is we are given an adjacency list, right? So in the graph question that we had done, we knew that what is adjacency list. Here adjacency list will be of the size V. So basically there are V rows and each row will have like adjacent elements. So here how the list will be given to us, it will be like for 0, it will be 1, 2, 3. For 1, there are no elements that are connected. 2, there will be 4. 3, there are no elements, right? So adjacency list for this graph will sort of look like this. Let me just quickly show you how it is going to look. So it is going to look like 0, 1, 2, and then 3, and then 4, right? So I'm drawing the adjacency list for this graph. You should also be able to view it yourself. Now 0 is connected to 1, 2, and 3. 1 is not connected to anything, so only one size. 2 is connected to what? It is connected to only 4, so 2 sides. Then 3 is not connected to anything, 4 is not connected to anything, right? So this is how the adjacency list is going to look. So the size of the list is going, the number of rows is going to be V, but the number of columns depends upon the number of adjacent elements or the number of edges that are there. But now here the tricky part that happens is in the previous questions that we have done till now for level order traversal, we used to have like queue of nodes because we used to be dealing with trees, so we had nodes. Here we have only what? We have only integers. Now what are we going to do? Why we used to have nodes? We used to have nodes because we had to go to the left and the right children, right? So they basically, it was way to go to the children somehow, right? Here, how can we go to the children? Here we can go to the children using this adjacency list. So here we do not need the queue of nodes. Here we are going to deal with integers itself, but we are going to use the adjacency list to go to the adjacent elements. I hope you have understood. If you have any doubts, let me know. Here it is very important to understand that why there we were taking queue of nodes, and here since node is not there, we have to take queue of integers. But how do we go to the children elements? We have to go to the children elements how using the adjacency list. So it is very important to understand these small pointers. I hope you are able to understand. So what do? I push the first element, right? Now what am I going to do? I'm going to put a while loop. Okay, and I'm going to say while q is not empty. I am going to take out the first element because it is an integer. I can just call it int f. So because it is the frontmost element, I'm calling it f. Okay, so q ka front I have. Now what am I going to do? I'm going to pop this element out so that I don't forget it. Otherwise, I'll end up in a forever while loop. I'll end up having a segmentation part, right? So now what am I going to do is I'm going to push that in the vector that I have. Okay, what else? Now what we used to do earlier, we used to visit all the children. That if there's a left child, I used to push it to the queue. If there's a right child, I used to push it to the queue, right? But since that is not the case, what am I going to do over here? I am going through the adjacency list that I have. So for all the elements that are adjacent to this particular element, so adjacency list for what? For f. So this integer that we have, for each element that is connected to that particular element, I mean, this is a directed graph, right? So in that particular row, for all the elements, what am I going to do? I am going to push those elements to the queue, right? Is this much clear, guys? So what we have done till now, instead of pushing to the left and the child nodes, here we are pushing. Samir is saying this video helps me a lot. Thank you so much. Mansoor is saying the first limit of this adjacency list is the source node, right? Right, exactly. So what we are doing over here is, that is a good question. So here we are visiting all the nodes one by one. So after this, the point that I'm going to be saying that will make this point very, very clear, Mansoor. Just stay with me. First of all, there is a huge problem over here. So first thing that we noticed in a graph is that, there are no nodes, there are adjacent elements. So we have to deal with the adjacency list, right? The second point that I said that, okay, there can be a cycle. We have to avoid a cycle. So this is actually not going to work. So let's compile and see whether this works or not. For this example, it might work. Yeah, this has worked for this example. I'm going to submit and I'm going to end up having, like, my cases won't pass. So now I want you to tell me the comments that why the cases are not passing. What is the mistake over here? Okay, so I guess there's some problem with the net. I guess it's a bit slow. So can you just quickly tell me, I'm telling you that all the cases won't pass over here. I want one of you to guess and tell me that to understand that why. Okay. So Shivai is saying that visited array is required for every vertex. Very good, Shivai. So here I've passed only 5 cases. See here, if you notice the output over here, the correct output is supposed to be this. So I'm visiting the elements like this, but my output is this. So if I notice what is the problem over here is, I am actually visiting the elements again and again. If you see the element 9 itself, I have visited how many times? 9, 9, 9, 9, 7, 7, 7, 7, right? So this is the problem over here, right? So we will be revisiting already visited node. So what are we going to do over here is, as you all have already guessed, we are going to have a vector visited, right? I'm going to just keep it of Boolean because we just need two values, true and false. How big is this vector? It is of the size V because that is the number of nodes that we have. I'm just going to keep all the initial elements as false. Okay. Now, as I push the elements into the queue, what do I need to do? I need to mark them as visited. So here I have pushed the 0th element, so I'm going to visit it as 0. That's true. Okay. Again, there are a lot of mistakes that we can make over here, and I want you to understand those. So I'm going to first talk about them. Okay. Here, as I am pushing the elements, I'm going to mark them as true. And let's see if I am able to pass all the test cases here or not. And while I do that, there's another question that I have for you. If this visited, instead of marking over here, I mark it outside, outside of this for loop, is this going to work or is it not going to work? Okay, so let me say my question again, that I'm marking my visited elements, right? Okay, so I'm marking them visited. I'm going to push them only if they are not visited, right? So one second. X is true and I'm going to push them. So if not visited of X, I have to push these elements. So basically this, right? So I obviously am going to push the elements only if they are not visited. Otherwise there's no point of putting the visited check, right? So let me submit this. My question is that instead of marking the visited over here inside the for loop, if I mark it outside, am I going to pass the test cases or not? Okay, so I need you to tell me in the comments, is it going to work or not? Right now we have passed all the test cases. Now what am I going to do is, Mansoor is saying it should work. Okay, so now what I do is I take it outside and I put it over here. Okay, now let's see what is going to happen. So here I still, the check is there. If it is not visited, I'm not going to push it. But here I am marking it outside, like I'm going to mark it when I come across the element. So I'm here, what I'm doing, I'm going to mark the frontmost element. So I don't need this also, right? So I'm visiting the elements as I'm coming across them. Like instead of pushing, while pushing into the queue, I am marking them visited as I'm popping them out, right? That is what I'm doing over here. Let's see whether this is going to pass my test cases or not. So Manzoor said that it should work. Paris is saying it should work, but it did not work. So this is again a very common mistake that you guys will make. So this is the reason I made the mistake intentionally. I wanted you guys to think about it. Now let's try to understand why it won't work. Okay. Now suppose I am over here. I am at 2. Okay. Let's take our queue. So the Okay, let us take a very good example to understand this. So suppose my queue, right now I'm at 2 element. I have pushed it. Okay. So I don't mark it as visited right now. Okay. Let's start from the starting. We start from 0. We, uh, we have pushed it to the queue. Okay. Let me write like this. So 0, I have visited, so visited true, right? Let me write. So visited true, 0 is visited. Okay. Now what I do, I come to 2, but I don't mark it as visited right now. I have just popped what? I have popped 0. So now I go to the adjacent elements of 0. What am I going to do? I am going to see, is 1, 2, 3 visited? No, it is not visited. Now in my queue, I am going to push 1, 2 and 3. Okay. Now what am I going to do? I am going to come outside. Now 1, I am going to pop out 1. Okay. Now let's say that from this 2 element, this 4 is there. Now suppose there was an element from 4 to again 2. Now we have not yet marked, let's say there was like this. So 1 to 4 was also connected. Okay. Now when I pop out 4, I'm going to push it to the queue. Now what happens is that because 1 is not marked as true, I'm going to again take, like, I'm going to retake this 4. Now take the example when 1 is also connected to 4 and when 2 is also connected to 4. I am marking them as visited while coming back, like from when I'm popping out of the queue. So it is not going to work, right? So are you guys understanding? Instead of marking them as visited while I am popping, I should mark it them while I'm pushing. Otherwise, what is going to happen is I've already pushed an element. Now, that element could also be an adjacent element of the other element that I'm going to visit, right? So I have not marked 2, but it is in the queue somewhere, right? It is already there in the queue. Since it is not visited right now and I can push it again, okay? Only when I pop it, I'm marking it as true. So it is not going to work. Is this clear, guys? Paris, Mansoor, Sham, those who said that it is going to work. Are you able to understand? Some element is already in the queue. I've not marked it as visited. When I pop it, only then you are marking it as visited. It is not going to work because it could be adjacent element of another, right? So when you're going to push it into the queue itself, you have to mark it as true, right? Great. So Mansoor got it. So like this, I needed to take more examples to dry run, right? So these are the small mistakes that we are going to make. Interviewer can really confuse you. And you could also make this mistake, right? That instead of marking them as visited while pushing, I might mark them as visited while popping. But there's a very small difference over here, and we have to understand these things. Okay. Now let's talk about the time and the space complexity. Here visiting, we are going through the adjacency list, right? So order of V plus E. Why V? So V is the number of elements. Now adjacent number of edges for adjacency list. So right. So time complexity is order of V plus E to go through all the elements from this adjacency list. But the space complexity is only order of V. Why? Because that is the number of vertices. That is the maximum size of the queue that we can have, right? So I've understood why time complexity will be order of V plus E, but space complexity will be only order of V because we are storing only the vertices and not the edges. So I hope you have understood this properly. Tomorrow we'll be doing DFS. So till now we were doing BFS of graph. So what we are going to do next is we are going to do DFS of a graph. Then we are going to be doing the hard questions, detect the cycle of directed and undirected graph. So I hope you are having fun, guys. Do show up. And if you are liking the series, please do share it with your friends. And always there is link in the description to try and do practice yourself so that you're actually writing the code also and not just listening to me. Okay, thank you so much for showing up. Bye.